Hi, I'm Chelsea, and today I'm going to demonstrate how to solve a projectile motion problem. So to begin, let me first explain what the problem is. In this problem that I've chosen, we have a diver that is diving off a 10-meter high cliff. His initial velocity is 2 meters per second, and he's diving off directly horizontally. What we want to know in this problem is what is his distance from the cliff horizontally and his height above the water at the time t equals 0.8 seconds. So to begin, the first thing we need to do in a projectile motion problem is draw a picture as well as choose a coordinate system. So in this problem, I've already drawn my coordinate system, and I've chosen the positive x direction to be horizontal to the right and the positive y direction to be vertically down. You could very easily choose a positive y to be upwards, but I know that for this problem it may be a little easier and save us some negative signs if we are to choose positive to be down in the y direction. I've also labeled his starting point to be my origin, so y equals 0 meters and x equals 0 meters. On the side here, I have written my list of equations that I use for projectile motion, and I split them up into the x-coordinate and the y-coordinate. So now that we have all this information listed, there's another set of information that we need to list as well. Again, we will need to split it up into the x-coordinate and the y-coordinate, the horizontal and the vertical. So the first piece of information we need to use is our initial x velocity, so this horizontal velocity. Now he is jumping off, as the problem stated, horizontally with a 0-degree angle, so v naught x will simply be 2 meters per second. Okay. The acceleration in the x direction, in this case, will be 0 meters per second. Now, if the problem had stated that there was a wind he was jumping off across, or some other force acting on him, the acceleration wouldn't be 0. But in this problem, we can fortunately assume that it is. And this will simplify our problem because it means that the velocity in the x direction won't change. So Vx for the entire problem will be 2 meters per second. Looking at in the y direction, the up and down, our v naught y, okay, again he has jumped off horizontally, meaning there's no initial velocity in the y direction, so that's 0 meters per second. And the acceleration in the y direction, which is constant, will simply be g, which is 9.81 meters per second squared. If we were to choose positive y to be up, the acceleration is downwards, so in that case it would be negative. But here, because we chose positive y to be downwards, we can take the acceleration in the y direction to be positive, because the acceleration is in the positive direction. So now that we have all this initial information, we're ready to go and choose our equations. So first, let's look at finding how far from the cliff he is horizontally, our delta x. So for delta x, I'm going to choose this equation. Okay. And this is pretty simple. We know our v naught x and we know our t, so we can put values in for that. So 2 meters per second times 0.8 seconds will be 1.6 meters. Okay. Simple enough. And now to find delta y at the same time, we are going to choose this equation here. And again, v naught y, okay, so our initial y velocity in the y direction is 0. So we lose that term. So all we're left with is this part. And we can fill in numbers. Okay. And making that calculation, we get 3.14 meters. Okay, now we have to be careful once we get that. Unlike when we found delta x, the 1.6, and that being our final answer, this delta y that we found here is actually this distance traveled. So from his starting point to the height. We are interested in how high above the water he is. So knowing his starting height was 10 meters, what we need to do is actually subtract this value from that. And when we do so, we get 6.86 meters. And that again is above the water. And that's it. There are multiple other variations that can go with a projectile motion problem, and this toolbox here is your key to using all of them. The key is picking out what you know and what equation would be best. And that's it. Please visit our website at www.sandersontestprep.com. The link is in the description below. Thank you.